Let us take one more example on partial differentiation. And the question is, if u is equal to log of 10x plus 10y, then show that sine 2x del u del x plus sine 2y del u del y equal to 2. So we have given that u is equal to log of 10x plus 10y. Let us give it equation number 1. Then we have to show that, or we have to prove that sine 2x del 2u del x plus sine 2y del u del y, which is equal to 2. So what is our aim in this example? In this example, we have to first find what is the partial derivative of u with respect to x. U is given. And similarly, what is the partial derivative of u with respect to y? Then we will multiply del u del x by sine x and del u del y by uh, uh, sine 2y, and we simplify it, then we get the right hand side, which is equal to 2. So let us, what is our first aim? Our aim is to first find out what is the partial derivative of u with respect to x and what is the partial derivative of u with respect to y. Differentiating one partially with respect to x and y respectively, we have del u del x. So derivative of log x is 1 upon x. Derivative of log x is 1 upon x. And then again derivative of x. What is that? It is 10x plus 10y. Now, what is the derivative of 10x? Partial derivative of 10x with respect to x? It is sec square x. And partial derivative of 10y with respect to x, since x and y are independent, so the partial derivative of 10y with respect to x will be 0. So we have only sec square x upon 10x plus 10y. So this is the partial derivative of u with respect to x. Similarly, if you want to find out the partial derivative of u with respect to y, again same thing, partial derivative of log x is 1 upon x into partial derivative of 10x plus 10y with respect to y. If you want to find out the derivative of partial derivative of 10x with respect to y, so this will become 0 because x and y are independent. But this, what is the derivative of 10y with respect to y? It is nothing but sec square y and whole divided by 10x into 10x plus 10y. This is the equation number 3. Now we have to multiply these by sine 2x as given in the given expression and these by sine 2y and adding them. So let us do it here. Multiplying 2 by sine 2x and 3 by sine 2y and adding them, we have. So sine 2x into del u del x plus sine 2y into del u del y. Now sine 2x into sec square x upon 10x plus 10y. Sine 2y sec square y upon 10x plus 10y. Now let us convert this sec square into terms of cos square cos x. So now we can write down, and sine 2x is 2 sine x cos x. Sine 2x is 2 sine x cos x, and sec square x is 1 upon cos square x, so which is divisible by this, is we have divided it. Similarly, sine 2y is 2 sine y cos y. Again sec square y is 1 upon cos square y, so we have written like this, divided by cos square y. So now 1 cos x and 1 cos x will cancel, 1 cos y and 1 cos y will cancel, and here 2 sin x upon cos x is remaining in the first part. Similarly, here 2 sin y upon cos y is remaining. What is sin x upon cos x? This is nothing but 10x. So we can write down 2 10x, and similarly sin y upon cos y is again 10x, so we can write down 10y. Now what is the LCM? LCM is 10x plus 10y, so we can write down 2 10x plus 2 10y, and if we take 2 common, 10x plus 10y, and in the denominator it is again 10x plus 10y, so both should be cancelled and we have 2, which is the right hand side. Hence sine 2x plus sine 2x into partial derivative of u with respect to x plus sine 2y into del u del y, which is equal to 2. This is the desired result, hence proved. Thank you.